do a little bit of Quizlet. Bird searching. No bird searching today, but we're gonna do a couple little quick Quizlets. Let's try individual first here.
Yes.
Is Peyton missing today? Okay. Hold on, let me mark Peyton next real quick. Oops. I'll come back. Sorry. Yeah. Sure. Sure. That's fine. We waiting on anybody else? We're all in. All right. Here we go. I wish we could get a competition going with all my Iowa one students, like my first period and my fifth period together. I don't know, maybe we could do it at night, like sometime. Yep. 414-944. Man, ostriches. Holy cow. This is insane. You guys are good. What? This is literally, I'm going to time the next one. What in the world? What? That was crazy. That was like less than 10 seconds. That was nuts. I'm timing this next one. Whoa. Okay, everybody ready? Mark, get set, and I'm going to start it. Let's see how long this takes. This one's not as fast. This must be a harder group. I don't know. Maybe it was faster in my head.
No, it was definitely a lot faster.
It was right. Still though, 38 seconds at this point. Look at that. This time it's the Dolphins. Well, that was 48 seconds. All right, let's play with teams now. Use your real names, Tristan.
I could take your player. Because I you'd have to make CPU draft for you. So if you want to take this
All right, here we go. Oh, you didn't get in? Here we go. Do it. What took you so long?
I don't have it.
I feel like the more people, the slower it goes.
I don't have it.
Isn't it like ready to
Oh.
I don't have it. I'm pretty sure this is ready.
I have like 8.
Don't blow it, Stingray.
Oh!
Oh!
You're good. I know. Happens to the best of us.
City Bank's game now. What got you, Savannah? Which one got you? Oh, it's City Bank's game now.
No, it wasn't. Unless they get it wrong.
I don't have it.
Is it an owl? Is it the owls? As long as they don't blow it, it's the owls. All right. We'll shuffle teams real quick. Here we go. I switched it up. There we go.
Oh, yeah.
Can you get in? We'll let you in. It won't let you in. It won't let you in. We'll do it tomorrow. Is that cool?
I don't have it.
I don't know any of these ones I have. Go Alan.
You don't have it. I'm out.
I'm not even knowing you. You got them all.
Right. All righty. All right. All right. Put your Chromebooks down for just a few minutes. We'll open them back up in a minute. All right. So kind of like on the first day, they're just kind of giving you a little throwback here, Throwback Tuesday. If you remember, we started talking about experiments and we started looking at, I showed you a video going outside, right? We looked at the trees, so we made an observation, right? We talked about a hypothesis. You guys came up with theory, I'll never forget that. We looked at just that scientific process. Then we started looking at the independent and dependent variables, right? Okay, the dependent as measurement. Okay, or Greta switched up this year. I went in the room, I was like, whoa, she changed dependent as measurement to data and measurement. I like that too. So however it helps you remember it, that'd be great. And then independent tested, right? So what are we testing and what are we measuring? We've got that cause and the effect. Yeah, Tristan. Okay, yeah, I'll let you in a second here, buddy. So we looked at those graphs. I'm going to show you a quick little clip of a movie that a guy I met in Indianapolis made. It was this guy. I was at this conference, and he was at a booth for Ball State University, and I noticed he was wearing a Patagonia shirt. So I was like, I like this guy already. I like Patagonia stuff. So I'll tell you more about that later. But I was like, hey, this guy, I want to talk to this guy. So then he came up to me and he said, or I went up to him, I can't remember, and I said, hey, what are you selling? He said, well, I made this movie about this bird called juncos. And at this point, I had no idea about juncos, right? No clue at all. I mean, I knew they existed, but I didn't know how cool they were. And so he was like, we started talking. He's like, I want to work more with high school teachers. So I've gotten to know this movie pretty well. And we're going to watch kind of the intro clip about a guy named Rowan who started studying juncos and junco behavior. Okay, as you're watching this, it's like 4 minutes or something. Okay, I want you to think about his experiment. Okay, what he's doing to study juncos. Okay, and maybe that independent and dependent variable. Okay, so let's watch this and then we'll talk about it. In that article. Do you even know who Bobby Watson-Heiser is? She's an old, well, not old, she's a former PE teacher, and she's awesome.
William Rowan was an eccentric and talented man who had many interests, including art, writing, nature, and science. But perhaps his greatest passion was birds. Originally from Switzerland, he immigrated to Canada in 1919 to pursue a career as a biologist. For Rowan, the Canadian wilderness presented a highly underexplored outdoor laboratory, filled with biological discoveries waiting to be made. He was especially curious about bird migration, the annual journeys each spring and fall between breeding and wintering habitats. What was it that triggered birds to fly such great distances every year? How did they know when it was time to go and when it was time to return? Leading theories of the time suggested that temperature and barometric pressure were the key environmental cues that birds used to calibrate the seasonal changes in their biology. Rowan saw things differently. In 1924, Rowan accepted an offer from the University of Alberta to establish a new zoology program. It was there that he hypothesized that changing day length, not temperature or pressure, was the key environmental factor that triggered bird migration and reproduction. Further, he reasoned that if changing day length in any way affected the migratory impulse, it must do so through the seasonal growing and shrinking of the gonads. Rowan was not the first biologist to consider the importance of photoperiod, but he would be the first to directly test its role in animals. He devised an experiment involving a small population of captive birds that would be housed in 2 outdoor aviaries during the winter. The control group would be kept unmanipulated to observe and use for comparison with the experimental group. The 2 aviaries would be identical. However, the experimental cage would also have electric lights that would be left on past dark into the winter nights to simulate the increasing length of days birds would experience in spring. This pioneering experiment would make Rowan famous. But it didn't come easy. University of Alberta President Henry Marshall Torrey had very different ideas about science. For Torrey, science belonged in the lab, and only the lab. In the 1920s, zoology was focused on lab studies of invertebrates, fish, and amphibians. Many regarded studying birds, especially in the field, as a foolish scientific pursuit.
It's a waste of time.
Torrey repeatedly discouraged Rowan and gave stern warnings to give up on his ornithological research. Fortunately for science, Rowan didn't listen, and he carried out his fieldwork in secrecy. As the nights got longer and the temperatures dropped, he made his day-length experiment a reality, working in secrecy on his own property on nights and weekends. The bird he chose to work with was the dark-eyed junco, a common wintering songbird in Alberta that migrated northwards each spring. Juncos were an easy choice, as they were abundant in small flocks, easy to capture, and thrived in captivity. The experimental juncos received electric light well into the night for 3 months, with the duration of light increasing 5 minutes per day to simulate spring and early summer. Except for the artificial lights, the birds lived in winter conditions. In fact, it was an especially cold winter, even by Canadian standards. Every 2 weeks, Rowan recorded behavioral observations and measured the size of individual birds' gonads. And just as Rowan had hypothesized, the increasing light caused the experimental junco's gonads to increase in size. And by the end of the study, they courted and sang as if it were spring.
All right. So let's talk about this. And all right, so we got the dark-eyed junco. We got this guy who's like, I think I want to, I think I get some ideas about migration. And remember, they all said like that it was, they thought bird migration had to do with not light, but what? Yeah, sure. Light, but what? What was it? Temperature is what they originally thought. They thought it was temperature, right? Here he's got this really stinking cold winter, right? But something happened when he added light. What happened to the juncos when he added light to the cage? They started singing, right? Okay, so if I'm a bird, okay, why do I sing? Attract the females, right? If you were a bird, that's a female, or I mean, sorry, that's a male trying to attract the female, okay? The females don't really sing the big, loud songs like males do. They want to attract the females, so the females actually will be attracted to the bird based on how well the bird sings its song, how loud it is. So if you stink at singing, the bird, it's like, I don't want you. I'm going to go over here. And I'm gonna go with this guy because he sings better, he sings louder, and that means like, yeah, he's ready. He's ready for making eggs, right? Okay, so how do birds, like what's happening physiologically in their bodies to make them sing more? All right, we do have a more biological term for that. Testes, right? Okay, take balls also gets it, but there you go. Okay, so what happens to their testicles? Did you catch that in the first part? They get bigger, right? And how do their testicles? Why are they? What's happening inside the testicles to make them bigger? Circulation, right? That hormone, okay, testosterone, In fact, there's other studies. I read a study recently where they just took a syringe full of testosterone, put it into the bird, and the bird would not stop singing. It almost like collapsed because it was like cracked out on testosterone. Okay, right? Okay, so what causes that? It wasn't temperature, but what caused those testes? The light, right? So why does light have something to do with causing the birds to sing more? Like, and affect that? Yes.
There's more light like during the spring.
Yes. What's happening to our day length now? It's getting shorter, right? Soon we'll have those, equinoxes where it's the same day and night, 12 and 12, right? And then we'll have the longest night, shortest day, and then it'll be equal. Then we'll have the longest day, light of the year, right? So in the spring, the days start getting longer, right? If the days are getting longer, that means more light. That means there's a signal to say, birds, you start singing because now is the time to mate. Why don't birds mate in the winter in Indiana? Yeah.
Isn't it too cold and their eggs would
Yeah, their eggs would freeze, right? Yeah, you could. The bird doesn't have enough heat to keep them warm, right? Okay. So this was a revolutionary experiment. This was huge for the ornithology community. So let's look at his two cages. One cage had just regular light, okay? The other had artificial light. Which was the control?
The light levels and weight.
Yeah, just the cage with no artificial light, right? Okay. What did we change? The light, right? So is that the independent or dependent variable? That's independent, right? We changed something. That's what I'm testing. What am I measuring? If they sing or not, right? And also testicle size, right? Yeah, right. We cut those open and see. That's kind of, they didn't show that part, okay? Right? But definitely increased in size, right? Are you all with me on that? Control is the cage by itself, no artificial light. The cage with the artificial light, that's what we changed, okay? We measured when those birds started singing. Did the natural light birds start singing the same time as the artificial light birds? No. So Rowan concluded it's got to be the light, right? That's what's happening. Of course, this experiment was repeated and then proved to be true. All right, go ahead and open up your Google Classroom. If you're watching from home, okay, go ahead and open up Google Classroom and go to classwork, and you're going to open up a document that says Bikini Bottom, okay, independent, dependent worksheet, okay? SpongeBob fans out there? Any SpongeBob fans? Yeah. Okay, good. All right. You don't like SpongeBob? That's all right, man. I've not let my kids watch SpongeBob yet. Not that I haven't let them. They just haven't asked, I guess. I'm expecting them to go through a serious SpongeBob phase at some point. Like it'll hit. They're not doing the Paw Patrol anymore. No offense, Peyton. Yeah. What happened?
They were gonna take it down because the police dog was a good boy.
The what?
The police dog was a good boy, so the
Please, what dog?
police dog was a
Showing
good
that
boy.
the police were good or whatever.
I can't believe that.
Because they're really smart.
I like that. My kids were hardcore Paw Patrol folks. All right, here we go. Let's look at Paddy Power. Let's read this together. Mr. Crab wants to make Bikini Bottom's a nicer place to live. He has created a new sauce that he thinks will reduce the production of body gas associated with eating Krabby Patties from the Krusty Krab. He recruits 100 customers with a history of gas problems. That's farts, kids, right? He has 50 of them, group A, eat Krabby Patties with the new sauce. The other 50 That's group B. Eat Krabby Patties with a sauce that looks just like the new sauce, but is really just the normal mixture of mayonnaise and food coloring. Okay, both groups were told they were getting a sauce that would reduce gas production. 2 hours after eating Krabby Patties, 30 customers in Group A reported having fewer gas problems, and 8 customers in Group B reported having fewer gas problems. All right, so let's look at the control, independent, and dependent variables and the conclusion here together. Okay, so think for a second. Okay, what do you think, which group, Group A or Group B, is the control? You are correct. Why did you choose B, Dominic?
I don't know, because it's like the original.
Yeah, it's the original. Remember, look for some of those key words. What would be the key word in that sentence with the Group B? Like what word? It's like, this tells me this is the control. There's one word that should be like ding, 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 ding. Which one is that? Yeah. Okay. Yeah. Original. I'll take that. I was looking for normal, right? It's the normal mixture, right? Okay. That's not the new one. That's just the normal one, right? Okay. Looks like the new sauce, but it's just that normal mixture. When you see normal, you're like, that's control. All right. What are we changing here? What are we trying to test? Okay, that's sauce, right? Okay, so that new sauce is what's happening. So I hope you're typing in here. Okay, the control group. Okay, group B. Okay, the independent variable, the new sauce. Okay, and what are we measuring? Yeah, the gas, right? Okay, so remember, Mr. Krabs thought that the new sauce would reduce the amount of farts, right? That's his hypothesis. That's what we're trying to figure out, right? Okay, so we're going to measure the amount of farts and who says they have gas problems. Okay, so what do you think? Did the new sauce, okay, have a good effect? Okay, it says Group A reported having fewer gas problems and 8 customers in Group B. So we have 30 and 8. Is that significant though? 30 out of 100. Probably not statistically significant, but there's something to maybe go with that. Paulie. Oh, sorry, 30 out of 50. That's right. Oh, because he got, yeah. Oh, yeah, then that would be statistically. Thank you. I should learn how to read. Okay. Sorry. So, yeah, that's pretty good. 30 out of 50, okay, versus 8 out of 50 in Group B. Okay, so, yeah, the new sauce, it's going to cure you. All right. Let's do the second one, the slimatosis. SpongeBob notices his pal Gary is suffering from slimatosis, which occurs when the shell develops a nasty slime and gives off a horrible odor. His friend Patrick tells him that rubbing seaweed on the shell is the perfect cure, while Sandy says that drinking Dr. Kelp will be a better cure. SpongeBob decides to test this cure by rubbing Gary with seaweed for 1 week and having him drink Dr. Kelp. After a week of treatment, the slime is gone and Gary's shell smells better. Okay? What's the initial observation here? What are we observing? Yeah, Gary's shell, right? Finn, what were you going to say? Yeah, that there's slime on there, right? It's got, and it stinks. That's what we observed, right? It's like going outside and observing those shells, right? Or observing those trees. Okay, in this case, okay, his friend Patrick says that rubbing seaweed is the perfect cure, while Sandy says that drinking kelp will be a better cure. Okay, so what is the independent variable? What are we changing here? Yeah.
Like the product used.
Right, the product, right? So it could be Dr. Kelp, okay? It could be seaweed. right? So you can put Dr. Kelp and seaweed here in number 2. And what are we measuring? What are we measuring here? Yeah, if he still has slime, right? But there's a problem with this experiment. Holly, what's the problem with this experiment? Yeah. Right. He's doing both at the same time, right? Okay. He did seaweed for a week and he drank Dr. Kelp. We don't know if it's the Dr. Kelp or the seaweed. A better experiment would be like try it a week with the seaweed. If the seaweed doesn't work, then try it with Dr. Kelp, right? Or have 2 different people, you know, Gary and Gary's cousin with the same shell. Okay. I want you to do number 3 for homework tonight. Okay. And number 4. And turn this in for tomorrow. So number 3 and number 4 on your own, you at home. Okay. Number 3 and number 4 should not take you too long, and we'll talk about them tomorrow. But please turn this in before class tomorrow. Turn this in before class tomorrow. I'll give you some points. Thanks, everybody.